far. So we're writing a program which, we're writing a program which first prompted the user for a value using cout. So we want to first do that. Please enter a value. Okay. And I'm putting this ENDL thing at the end. I don't really have to do that. It'll just leave the cursor after this. It'll just leave the cursor after the output cursor after the word value if I don't, and my input, the user will be inputting the value there. So I mean, I don't really have to put you don't always have to put an ENDL at the end of every statement. It's just if you want the output to go to the next line. And then I want to see into a variable. I haven't declared my variable yet, but I'll go back up and do that. Matter of fact, noticing that I hadn't declared my variable yet. You see the little red squiggly line under number there? That's there because, well, it says identifier number is undefined. It's always a good idea. I'm going to try to, not that I did this on purpose, but I am going to try to leave little errors in occasionally so we can look and read the error messages so you know how to recognize them when you get the errors. So here, whenever it says something's undefined, that usually means, if it's a variable, it means A, you forgot to declare it, or B, you spelt it differently than you spelt it when you declared it. And in this case, I had forgotten to declare this. So I'm going to go back up to the top and put in a declaration, and then the red squiggly line goes away. Okay, so now just logically, I've just read in a number, so and I want to print out one of two messages. I want to print out either it's positive or negative. So I'm going to write this a little different than I had it on the board. I'm going to say if number is less than 0, value is negative. Else value is positive. Okay, and again then again, so then once you have this in, see if you click on debug and start with that debugging to execute it. And if everything works correctly, we should see a little black box should pop up. It should say, please enter a value. And notice how the cursor is sitting right there, right after the word value. That's because I didn't put that ENDL at the end of that cout, so I left the output right there. And so I'll enter a value. Let's see. And it tells me the value is negative. I put it in -4, the value is negative, so that worked as it should. Whenever you actually have a program with two different paths, and that's something we've just introduced here, there's two different pathways through the program, right? When you have more than one pathway, when you go to test that program, you always want to be sure to test every pathway in the program. So I hear somebody's dinging. Did something not work?
Oh, no, I accidentally hit started debugging.
Oh, okay. Now, here's something I want to point out. Let's suppose, so everybody has this working, right? Yeah, okay, I think, because I don't hear anybody saying no, they don't. If it doesn't work, let me know so that I can come and peek at it and you'll be with us. Okay, so if everybody's works, and let's suppose if the value is positive, I also want to print out, let's see, I just want to put another statement here, so I'll just print out good job. So if the value is positive, not only do I want to print out the value is positive, but I want to print out good job on the next line. Okay? Now looking at the program, the way it is up there, it kind of looks, it reads like, well, if the number's negative, it's going to print out value is negative, and that's it. Otherwise, if the value's positive, it's going to print out it's positive and print out good job. Whoops. Tell me why I have a little squiggly line here.
The chevron.
Yeah, I don't have the insertion operator. Okay, so let's just look at how this runs. Let's run this and put in a negative value. I'm expecting, and you know, when you run a program, you should always particularly the first time, you should always know what you're expecting so you know if it worked or not. So here, looking at this, I expect if I type in a negative value that it's going to print value as negative, like it did before. So if I run this and I type in -3, wow, that's kind of odd. It did print out value as negative, but then it printed out good job. Okay, now that might or might not be a surprise, but because you know we have these things indented really nicely, but you know what? Again, remember I told you the rule with this if-else thing is the if can be followed by one statement. The else can be followed by one statement. Okay, so the fact that this happens to be indented means absolutely nothing to C++. And C++, because as I mentioned, C++ doesn't even pay any attention to the indentation. The first thing C++ does actually is remove most of the blanks from the program before it even looks at it. So the fact that you indented it, that's for your reading. So C++ just thinks, C++ kind of sees it this way. Okay, this is the one up here. There's one statement following the if. There's one statement following the else. This good job thing just happens to be the next statement in the program. So it's going to print that out in any case, regardless of whether the number was positive or negative. Okay, so that's why we got good job with the negative input. But if what we really want is the way I was trying to indent it there, if what we really want is the good job only to be printed if a positive value is provided, I have to somehow take these two statements and make them one statement, because the syntax, the rules of the language say that after an else you can have one statement. So if you want to put a bunch of statements in a place where only one statement's allowed, which is what I'm trying to do here, I want to put two statements in a place that one statement's allowed, you can use something called a compound statement or a block statement. In other words, you can put these curly braces around them. When you put curly braces around a statement, what you're doing is making around a group of statements, what you're doing is making that group of statements into one statement. Okay, so now I can put them there, or I can put this up on the previous line. I tend to put it on the previous line just to save space. But either way, you have to enclose. The enclosing, you can do it either way. I'm enclosing these two statements with the curly braces. That makes them one statement. So then that's what's allowed there. Okay? So you want to keep that in mind, because that's going to become very helpful, because most of the time you want to do something that involves more than one statement. And you're going to need those curly braces. So let's just double check that this worked the way that I thought it would. Okay, so I'm going to put in a negative again and just make sure that the negative doesn't print good job anymore. Okay, and it just says value is negative. Make sure yours works. Okay, and so that's the deal with curly braces. So they aren't required. They are not required when you just have one statement. I think, Paul, to answer your question before, right? Yeah. But I mean, you can put them. You can do it, and sometimes, you know, people do, just to get in the habit, but they're not required. Okay, like this putting these curly braces around this one statement doesn't make any difference in the way the program will execute, because there is only one statement there. But down here, I did need them. Okay. Okay, so that's how the syntax works. And sometimes people always put curly braces around just so if they want to go back and update and add another statement in here, they've already got their curly braces. That's another way to think about it. Okay, so are there any questions about that? Okay, and now let's look at just see what I was talking about before on the board. I just inadvertently, as I'm typing, because I'm in the habit of putting semicolons at the end of every statement. Suppose I put a semicolon there. Let's just look at what happens. See, actually, I know it's not going to run, so I'm not going to go to debug. Usually you go right to debug and say start without debugging if you're pretty sure it's going to run. If you think it might not run and you really want to just see the compile errors, build compile and give you those. Or actually, I probably didn't even have to say that. The curly brace was probably already up there and I just wasn't noticing. But again, just as I was talking about up at the board, when I put this semicolon up here, by mistake, I'm getting a curly brace down here with the else, okay? Which could be misleading because that's not at all where the problem is. The else is fine, right? The else is fine. It's just that C++ looks at this and it sees, oh, number less than 0, semicolon, so it assumes that if number is less than 0, the one statement it wants to execute is this empty statement that does nothing. And then this cout value is negative is the next statement in the program as far as C++ is concerned, and then suddenly it sees this else kind of out of nowhere, okay? Because the if statement was already done, and the else doesn't have anything that it belongs to. So you want to kind of be able to watch out for stuff like that. Okay. So let's see. Let's add something to this program. Let's suppose, I'm even going to put a comments. I tell you to make comments, and I expect them in your program, so I guess I should type them on the screen when I'm doing it. Let's suppose we want to change this program a little bit. Right now we have it set up so that we can tell if a value is positive or negative. But let's suppose what we really wanted to do with the program was, let's see, read in value, and if it's positive, print output a message indicating if the value is positive, not positive, I'm sorry, is even or odd, and otherwise I'll print out an error message. So this is what this program's doing. Okay. Now, it's always a good idea to have a comment up at the top that tells what your program does. Just because as you get to the point where you have a lot of different programs, you'd like to be able to, you have a lot of different CPP files. You'd like to be able to, when you open one, you'd like to be able to look right away at the top and see, oh, is this the one I was looking for? Because once you start to have a lot of them, sometimes you forget what you put where. It's always a good idea to put your name up at the top as well. Okay. For my purposes, when you hand something in to me, it makes my life simpler if your name's up at the top. And again, in real life, remember I mentioned that somebody else is going to be possibly updating your program or for years later, or fixing bugs if they are in the bug fixing section of the company, and perhaps they are reading your code and they're confused, and if you still work there, they might come over and say, hey, do you remember when you wrote this? And they might want to talk to you. So it's a good idea to have your name at the top of your code, so somebody can refer to you if they need to. Okay, so we're going to change this program, and everybody had this working so far, right? And so what we want to do is if the number was negative, we wanted to print out an error message. So here I'm going to say, change my little message a little bit to say value is negative, not processed. In other words, we don't like that. Down here, at the value, instead of saying that the value is positive, I want to do something else. Okay, I do have myself set up so that I can execute something if it's negative or execute something if it's positive. So down here is where I'm going to put what I wanted to do if it was positive. And what I just said we were going to do if it was positive was tell if it was even or odd, right? So if we're down here in our code, if right here where I am, if whatever I put there is executing, I already know that the number is positive because I wouldn't be in that else part. That wouldn't be executing unless the number was positive. So now I want to print out a message stating if the value is even or odd. So now we have another little situation where we're going to do one of two things. We're either going to be printing out that the number is even, or we're going to be printing out that the number is odd, right? So it's, again, one of two things, right? So what we just learned already is if we want to do one of two things, do we want to use that if-else statement, okay? So I'm going to be putting an if-else statement right here. This is called nesting, because what I'm actually doing is within an if-else statement, there's going to be another if-else statement. Okay, and again, it's going to be in the else part, so it'll only be executed if the else portion is executing. In other words, if the number is positive. So what I wanted to do, again, I'm going to have an if statement here, and I'm going to use my if statement to determine whether I want to print out that the number is even, or whether the number is odd. Okay, and I'm going to have to put something in here. I'm going to have to put something in here that indicates it's true if the number's even and not true if the number's odd. But again, this if-else statement is going within my else part. Okay. Now I still have my curly braces. Technically, for you purists, technically this whole thing's considered one statement, so I actually really don't need these curly braces, but it does make it easier to read in addition to the indentation, so I'm going to leave them there. So now I have to put something here that'll be true if the number's even and false if the number's odd. So let's see, anybody have any ideas? So I have this variable number. I want to know if it's even or odd. How do I find out if something's even? How's a way I can find out if something's even or odd? If it's evenly divisible by 2, sure. So it's evenly divisible by 2. How can I tell if it's evenly divisible by 2? I can use the remainder. I can use the remainder operator, which actually you probably read about in Xi books, right? On week 2, we didn't talk about it in class because we didn't have class that week, but you saw in a couple weeks ago there was this operator. It looked like a percent sign. And what it does is it divides, it's sort of like division, except the result is the remainder as opposed to the divisor, the quotient. So say number was 5. Number divided by 2, 5 divided by 2 would be 2, but with a remainder of 1. So if number was 5, this result would be 1. It gives you the remainder, okay? So if there's no remainder, in other words, if the remainder equals 0, I know the number is even. Okay. So this is, again, here I'm using this equal sign. Okay, because I'm comparing two things. I'm not assigning anything. A common error is to just put one thing there. Okay. And again, the little squiggly line starts to be all come under number, which is not really where the problem is. There's certain times the compiler gets confused when it's trying to translate your program, and it'll give you a squiggly line, not exactly where the problem is. It's important to know your language rules, but it's when you're comparing, always use equal, not single equal. So if this is true, if the result of this math operation here is equal to 0, we'll print out the number's even. Otherwise, we'll print out that the number is odd. Okay, so let's run this and see if it works. Now here, notice too, if we're really testing this, to thoroughly test it, we'd have to give 3 tests. We'd have to give a test where the number was negative, because there's 3 pathways through the program. We'd have to test if the number was negative, because that's only going to execute this. and then we'd have to test with make two tests with positive numbers, one where we had a positive even and one where we had a positive odd, to make sure that both of these, to make sure that the program thoroughly is working correct in all situations. So let's see, I'm pretty sure this is going to work, so I'll just debug it. Let's see. Okay, so I'm going to type in a 46, and it tells me 46 is even. Well, that looks good. I think it is. I'm going to try it again. I don't know for sure if my program works in all cases because there's 3 different pathways through the program. I'm going to type in 37. Okay, and that tells me the number's odd. So again, that is executing different code, right? One time I executed this statement, one time I executed that statement. And then to be totally sure, to start to feel really confident about this, I want to test it one more time with a negative value, and I get my error message. Okay, so that's how we can nest something. So you are allowed to put one if else inside of another, and matter of fact, you're allowed to do it as many times as you need to. If for some reason there was something else I wanted to do, if the number was even, if I wanted to test if it was also divisible by 6, I could put another if else right here. Okay, again, I'd want to use curly braces around stuff, so you end up with a situation, you do end up sometimes with, when you're doing this stuff, with a lot of curly braces. That's why where the indentation becomes important, so you can kind of follow what you're doing, and also match up your curly braces more easily. So are there any questions about that? Did everybody get that working? Okay, so I have one more, I think, thing that I want to do, or maybe 2. Well, 1. Let's see. I want to actually, yeah, I'm gonna put a comment around here so I don't have to delete it. You notice you can, if you want to put a comment just on one line, like I did up here, you use that // and both these lines are comments. Or if I have a whole block of code that I want to comment out, which is going to be the case with this, I can just enclose the whole thing in / and / with no spaces in between here. Okay, and this whole thing is commented. Okay. And I'm just doing that so it remains in the file. A lot of times if you're doing this demo stuff with me, if you save the file at the end, you have something to go back and look at, you know. Okay. So I'm gonna change the program a little bit. I'm gonna rewrite the same thing, but a little bit differently. Initially when we wrote this, we started out by checking if it was positive, and if it wasn't, we had another if else. This program actually can be written without a little bit differently. Another way that I could write this program, I could say, well, I know I wanted to print out the number as even if the number was greater than 0 and if the number was even. Okay, there is something I do want to print out. I do want to print out value is even if both of these conditions are true, if the number is positive and if the number is even. And so there's an operator. It's not a relational operator like the ones that I listed over there. Relational operators give you relationships between two values. This is called a Boolean operator because it expects to be used to connect two different expressions that might be true or false. Over here, this number greater than 0, that might be true, that might be false. Over here, this number divided, number mod 2 equals 0, that situation might be true, it might be false. So I have something that might be true and false on both sides. By putting this ampersand in the middle, that stands for and. Okay, that means this is an and condition, basically. Right? And so this whole great big expression here is only going to be true if this part's true and that part's true. If either of the two parts are not true, this whole thing is false. Okay, so right now, let's see. Right now, what I have here will work correctly. It's not quite where I want to end up, but right now, the way the program will work is if I have a positive even value, it's going to tell me something about the value. Otherwise, it's going to tell me that it's odd or negative. We're going to add some more stuff to this so it works like the other one did initially, but I just want to make sure that this makes sense to everybody. So let's run this program a couple times. Try it with a positive even, and then something else. Let's see that it works. So a positive even, it should tell me, yeah, it's even. Or if I run it with a positive odd, it tells me it's either odd or negative. So my two situations work. Does everybody have this much working so far, and does everybody understand what we have here so far? Yes, yes? Yeah? Okay. So this program almost works the way the other one does. I'm trying to just kind of show you a different way of writing it. Except there's one case that I don't have. The initial program up here, I was able to tell if a number was odd separately, and right now what I've written so far can identify the even numbers, but I'm not identifying the odd numbers yet, right? Because there really are three situations in the program. It's even, it's odd, or it's negative. So, how I handle zero. How am I handling zero? I think I'm counting zero as a negative. I don't think I'm counting it as a positive, the way I have it, the test going. Yeah. But we could put something special in there for that as well. But now, there's something else. Sometimes, again, we have three different situations here. I was trying to do this kind of without nesting. So we have three situations here. It's even, or it's odd, or it's negative. So I'm going to handle the odd situation here. And the way I'm going to do that is I'm going to add something, and I'm going to say else if. Whoops. Okay, you can put a else if. And basically, the way an else if works is an else if is like sort of like the if part up here, except it only executes if the top part was false. So, in other words, if the number was not positive and was not even, then the statement's going to fall down to this else if. And whatever condition I put in here is going to be checked. So in here I'm going to say, well, if the number is positive and the number is odd, then I want to print out the value is odd. And otherwise, I'm going to print out the value as negative. So here I've, again, done the same kind of thing. But using, not really nesting anything, but using the fact that I can actually have multiple outcomes from one if-else statement, not just two, but here I have three different things that happen. So the way this works is if this first one is true, it's going to print out values even, and this whole situation, this whole statement is done executing. If this first thing is false, it's going to fall down to the else if and test that. And the condition in the else if that's true, then it'll print out the value's odd and it'll be over. Otherwise, if the first condition's false and the second condition's false, it'll fall through to this value is negative. Okay? So now this should do, if we test it 3 times, is with both a positive even, a positive odd, and a negative, it should work the same way as the other one. So here, it's with the even. I'm just testing mine. If it's even, that worked. If it's odd, it worked. And if it's negative, let's see, if it's negative, it worked. Okay. And again, once you start having these if, else if, and else's and all that kind of stuff in your program, you have to do multiple tests and test through every possible condition to make sure that it works. And Paul, you didn't like zero being called a negative. So let's do this. Let's add one more else if in here. We can have as many of these as we want. I'm going to put another else if right in here, and this will just catch the situation where the number is 0. Okay. So now we'll have 4 different possible outcomes of the program: an even, an odd, a 0, which probably isn't really even, odd, or anything, right? And it isn't really negative either. So we'll be reporting on that as well. So depending on the different conditions that you have, you can have as many of these else ifs as you want. Is that working for everybody? Okay, then if everybody has that working, there's just one more thing I want to point out. Let's see, I'm trying to look for a good place to put it here. Let's see. It doesn't really fit in with what we're doing here. So I think I'm gonna move my comment down so I can just comment all this out and just show you one more little example at the bottom of all this. So let's suppose something we also had wanted to know was if the value was between 1 and 100. It was in a particular range. Okay. Now, there's a couple different ways I can do this. So I want to print, so I have this variable number, and I want to know if it's between, I guess it was called number, not value. I want to know if it's between 1 and 100. Well, if it's within that range. Well, you know one way to do it right now. You know, if I wanted to know if number is between 1 and 100, well, for it to be between these two values, it would have to be greater than or equal to 1 and less than or equal to 100, right? Okay, and you probably understand this because we just talked about the and. So the only way that that would print, that the number is in the range, is if both those conditions, number is greater than equal to 1, or number is less than or equal to 100, both of those would have to be true for it to print the numbers in the range, right? Let's test that. And again, to really test it, I have to give two tests, one with the number in the range and one with the number not in the range, to make sure both those things work. Okay, so that's one way you can tell if something's within range. Another way, does everybody have that working? Yeah? Okay. Another way I could have done the same thing. I think I'm gonna move my comment down here. And I'm gonna cut and paste this and then edit it just to save myself some typing. Another way I could have tested this. If a number's within range, I could also find out if the number's between 1 and 100 if it's if the number's less than 0, or just like we have and, there's an or. So if the number's less than 100 or the number is, less than 0 or the number is greater than 100. Doing the same thing here. If I'm checking just a different way. I'm checking for if it's negative or if it's greater than 100. Then it's out of the range. Otherwise, it's got to be in the range. Okay. Again, two ways of doing the same thing, but using different operators. This uses that or operator. And an or, the way an or works is a whole great big or expression will be true if one or the other expressions are true. They both don't have to be true for an or, just one. So in this case, only one of those things can be true. A number can only be less than 0 or be greater than 100, but if either of them is true, I know that we're out of range. Okay? Does that make sense? The and and the or. Okay, well then if there aren't any questions about this, then we're going to move right over to our lab.